All right, you lucky kids. I'm changing colors. So this is going to be exciting. All right, third video involving the introduction to integrals. This involves just some reminders about how to clean up ahead of time. 3x minus 5, we'll say, to the third power dx. Okay, so sometimes you have to kind of rewrite to get things started. Okay. Video 2 was all about e and natural log, and I said if you have x in the denominator, then you think of it as a natural log. Okay, this one I don't have x, I have x to the third. So this is not a natural log situation because it's not to the first. So I need to rewrite this thing before I can begin because I'm going to be able to just use my regular derivative rules. So rewrite that using -3. If you had a coefficient up there to start with, it would just stay in front. Okay, so now I'm ready for my rules. My rules say add 1 to your exponent. So that means I have 3x minus 5 to the -2 power. And then divide by your new exponent. Okay, now I have a chunk in parentheses. So this is like reverse chain rule. Chain rule, we used to have to multiply by the derivative of what's inside. This time I'm doing the opposite, so I'm going to divide by what's inside. So down here next to this -2, I also have to divide by the 3 because that's the derivative of what's inside. Okay, so the -2 is down there because that's my new exponent, and you always divide by your new exponent. The 3 is down there because that's the derivative of what's inside. And we're doing antiderivative, so I have to divide by it, not multiply by it. Okay, so clean up. I have, look at that. Everybody's on the bottom, right? Because this is a negative exponent, which means it's got to move. So there's nothing left on top, so that means there's 1. -2 times 3 is -6. And then I have 3x minus 5 squared on the bottom. Then don't forget your goofy c. The only other thing you do is normally we don't put negatives in the denominator. So I would just bring that up top because that looks better. I don't know about this color. I don't know what it is. It's like, ooh, you know why I don't like it? It's UT like orange. That's rude. Okay. That's the first one. That's the first cleanup. Let's do some more where we have to clean up first. Let me get that ugliness out of the way. All right, let's take a look at this. Let's take a look at this little chunky kid right here. Not that I'm prejudiced against chunky kids. I sadly am one right now myself. But I'm doing it. I'm trying. Okay, look at that. So here's what I have to stress to you. For the love of all that is holy. Just like when you learn to do the derivatives, you learned you can't just take the derivative of this thing and multiply it times the derivative of that. Okay, you had the product rule. Antiderivative is the same thing. You can't take the antiderivative of that and the antiderivative of that and squash it together. Okay, and there... Wait, I keep hitting things. Can you hear me? You don't know. I can't even... Well, whatever. I guess you'll tell me tomorrow if you can hear me or not. I keep hitting buttons. Okay, so in cleanup... Here's what you're going to have to do. First of all, we don't work with radicals, so I'm going to change that to x to the 1/2 power. Then I have 1 minus x squared dx. Okay, it's not great, but that's what we're going to do right now. In Calc 2, you'll learn other ways to handle it, but right now the only thing we can do is we're going to multiply all this out. We're going to square that, and then we're going to distribute the x to the 1/2 power. Okay, we're doing it. Just deal with it. X to the 1/2 power, 1 minus x. My dog keeps barking. She doesn't understand why. She's being forced to be outside on such a beautiful day. Distribute, 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 distribute. All right, so you're going to have x to the 1/2 power times 1. I get -x, and another -x is -2x. And then -x times -x is plus x squared. Okay, that's what I get. Now you've got to distribute this x to the 1/2 power to everybody. Okay, follow me. All right, x to the 1/2 power times 1 is x to the 1/2 power. X to the 1/2 power times negative 2x. Okay, so I get negative 2. X to the first, don't forget it does have a little 1 down here. X to the first times x to the 1/2 power. This is where you add exponents. 1/2 plus 1 is 3/2. So it's x to the 3/2. And then you have x to the 1/2 power times x squared. Add your exponents. 1/2 plus 4/2 is 5/2. So it's plus x to the 5/2 power. You haven't done any calculus yet. All you're doing right now is algebra 1. Now you're ready to do calculus. So we're going to use our antiderivative rules. Add 1 to your exponent. That gives you x to the 3/2. Divide by your new exponent. When you divide by fractions, that means you flip it and multiply. So we multiply by 2/3. Okay? Second one, I'm going to bring down the old negative 2. Well, that was a cute little sigh. Did you hear it? Oh, what's so cute? Add 1 to your exponent. That means I'm adding 3/2. So I get x to the 5/2. Then you have to divide by your new exponent, which means multiply by the reciprocal, which is 2/5. I'm about out of room up in her. Up in here. Add 1 to your exponent, you get 7/2. So I got x to the 7/2 multiplied by the reciprocal, which is 2/7. Okay, now it's time for cleanup. Let's clean up in pink, shall we? 2x to the 3/2 power over 3. Minus, now I've got this 2 times this 2, which is 4. So it's 4x to the 5/2 power over 5 plus 2x to the 7/2 power over 7. All right, here's the dealio, peoples. I don't want to do it. You don't want to do it, but we have to do it, okay? We're not going to leave 3 answers when there's nothing in the denominator except for numbers. We need to get a common denominator and just make this one ugly fraction. So let's do it. Common denominator between 3, 5, and 7. We're going to end up multiplying all 3 together. And it looks like 105 is the smallest number they're all going to go into. I know that because they're prime. So in order to change 3 into 105, I have to multiply top and bottom by 35. In order to change 5 to 105, I have to multiply top and bottom by 21. And for 7, I have to multiply top and bottom by 15. Gross. So I have, what color would you like your answer? What color? Maybe a new color. A surprise. A surprise. 70x to the 3/2 power over 105, right? Because you had your 2 times your 35. Minus 4 times 21 gives us 84x to the 5/2 power over 105. Oh man, why am I writing this as 3 separate fractions? I know I'm going to combine them. Dang it. 30, because I have 2 times 15. X to the 7/2 over 105. They all have 105. You're going to combine them all into one stupid fraction. 7x to the 3/2 power minus 84x to the 5/2 power plus 30x to the 7/2 power. All that's over 105. Don't forget your stupid c. That was ugly. I mean, your little c. Okay, it's not pretty. I mean, I'm not going to say it's pretty. I'm going to leave it like that. I'm not going to go back and change it to radical. I'm just not doing it, and you can't make me because you're not here. So there you go. So that was 2 problems where you have to rewrite. I'm going to do one more. One more problem. Okay, so remember this is a method. Sometimes you're going to have to rewrite. So what if it starts off like this? What if it starts off like this? 3x to the 3rd plus x squared minus 5 over 2x squared. Okay, let's say we have that dx, right? There's no anti-quotient rule. And if you were taking derivatives, you would have had to use quotient rule, but there's no anti-quotient rule here. So, again, a Calc 2 thing that you'll learn how to do is you'll learn how to do other methods to do this. Right now, we can still do this one. In fact, really, this is the easiest way to do this particular problem by distributing here. So you were going to go ahead and separate this, divide all those by 2x squared, because that's what it means anyway. So we're going to write that as 3 separate fractions over 2x squared. Okay, and then simplify. So we get, let's see, over here these x's cancel. We're left with just 1x on top. 3x over 2. Okay, here the x squareds cancel. I'm left with just 1/2. That's kind of nice. This one I'm left with, okay, now remember, we don't write exponents on the bottom. So this is 5 halves x to the negative 2. Okay, that's what I have. Dx. All that's just rewrite. Now you've got to do derivative. I got to scoot. I got all kinds of scooting that's got to happen. You know what I miss? I miss pink. There we go. Okay, derivative time. Ready? Add 1 to your exponent. Now remember, I have x to the first. Your coefficient goes along for the ride. My coefficient is 3 halves. X to the first plus 1 gives me x squared. Divide by your new exponent. That's what I have. Okay, 1/2 x. So I have no x's. When you add 1 to your exponent, you get x to the first. Remember, when it's a constant, think of it as x to the 0 power. Add 1 and you get x to the first. I don't need to divide by 1 because that's silly. Add 1 to your exponent. There's my coefficient. I get x to the negative 1 power. Divide by your new exponent, which is negative 1. So 3 halves divided by 2 is what I have right here. I have a fraction on top of a fraction. That just goes down there. So I have 3x squared over 4 plus 1x. Why did I write 1? X over 2. This minus right here is going to multiply with this minus right here, or divide, whatever, and it becomes positive. So that's plus. And then your x is in the denominator, so it's 5 over 2x plus c. And that's it. I'm not getting a common denominator because some of them have x's, some of them don't. I'm just leaving it alone. So that's what we have right there. That is evaluating the indefinite integral. So video 3 was really more about how you need to rewrite sometimes before you can do the derivatives. So now you're ready to do all your homework assignments for tonight. And I'll see you in class tomorrow. Unless you're watching this on Wednesday, Rolls Royce. In which case, I will see you in a few minutes. Bye.